Hello, welcome to the section of Mastering Statistics. Here we're going to talk about what we call measures of relative position, which are called quartiles in your data set. Mostly I'm presenting this for two reasons. One, because very likely someone will give you a data set and talk about the quartiles of the data set, and I'd like you to know what that means. It's kind of a definition thing. It's not hard, but if you don't know what the quartiles are, you're just not going to know what they're talking about. Second thing is, the quartiles are used to draw what we call box and whisker plots, which we'll learn about in the next section. And those are things that you'll come across quite frequently when studying any kind of large data set. And those box and whisker plots are drawn in part using these this quartile concept. This is very, very simple stuff, but just like anything else, if you don't have it explained in the right way, just kind of read some stuff in a book, it can be confusing. So let's go talk about quartiles, and I think you'll find that it's not very hard. So quartiles divide a data set up as follows. It divides up a data set as follows. So let me go ahead and change colors here. Let's say you have some data, right? So I'm going to say big letters, data. You have low values, medium values, and high values. So this line right here, this is going to represent all of my data values. I've got some low values, some medium values, and some high values, all right? So somewhere here in the middle of this data set, remember we talked about the median. We talked about the median. Now we're relabeling that in this section. We're calling it the second quartile, which is also called the median. It literally is the middle of the data set. So the second quartile, Q2, is called the median. Now, if you look on this side here, because the median cuts everything in half, then if you kind of were to look at your data again, I'll draw like another arrow right here. This is what we call the lower half of your data set, and this is what we call the upper half of your data set. All right? So if you look at the lower half from here to the median, or here to Q2, and if you look right in the middle there and kind of look at another median between here and what you found right here, this would be Q1. And then if you look at the upper half and find the middle right here, this would be Q3. So literally, the quartiles divide your data set up, just like what's on the board. You have the very middle of the road called Q2, which is the median. And then everything lower than that, you chop it in half again, that's called Q1, and then of everything above that, you chop it again, and it's called Q3. Now the thing that's weird about quartiles, you know, when I hear the word quartiles, I think quarters, right? So I think you're gonna like have 4 quartiles, right? So you gotta get that out of your head. There are 3 numbers, Q1, Q2, and Q3, that refers to the quartiles. There is no Q4. There's no fourth quarter like that. So the reason it uses the word quartiles is because here's region number 1, region number 2, region number 3, region number 4. So your quartiles do divide your data set into 4 regions. But in terms of what you write down, you only have 3 quartiles. They're Q1, Q2, and Q3. All right, so basically what you have, if I have to kind of summarize it here, Q1 is called the first quartile, and it's the number, it is the number greater than or equal to 25 of the data, 25% of the data. All right? Which makes sense because Q1 is here. So if you have data all down here, Q1 is greater than 25%. This is 25% of the data. Q1 is the number just right at 25% of the data. All right? And then we have Q2. So I'll say it's the number greater than or equal to 50% of the data. And that makes sense because the median Q2 is greater than 50%, greater than or equal to 50% of the data. And then Q3 is the number, what do you think it's going to be? 75% of the data. And that makes sense because Q3, since you're all the way over here, this is first quarter, second quarter, third quarter of the data, you're greater than or equal to 75% of the data. And the last thing I want to point out is Q2, as I've already said, is the median of your data set. In order to find Q1, really what you end up doing is kind of looking at the data only from the beginning up until the median, and you find a new median in the middle, and we call that Q1. In order to find Q3, we only look at data from the median, or Q2, up until the end. We find a new median here. We call it Q3. So really, finding quartiles is just an exercise in finding medians, and we've found many medians, and we already learned how to do that. First, you find Q2, which is the median of the whole thing. That chops your data set to upper half and lower half, and then you just find the median of the upper and the median of the lower, and those are your quartiles. So it's not a terribly hard concept, so let's go ahead and do some examples. So let's find the quartiles for the following data: 8, 9, 2, 10, 3, 5, 7, 12, and 15. So these are our data points. Remember, in order to find quartiles, which is basically finding medians, we want to order the data. That's kind of what we always do with these guys. So we want to go ahead and put them in order. So the lowest thing we have is 2. So we want to go from there. 2, 3, 5, 7, 8, 9, 10, 12, and 15. And I think you would agree this is everything. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything is put into order. Now the first thing we do is we go and find the middle of the entire data set. So we have 9 values. So if we look, this value, the 8, is exactly in the middle because I have 4 values below it and 4 values above it. So this one really is Q2 because that's the median of the entire thing. So we've already found one of them. Now, whenever we try to find Q1 or Q3, you got to realize that this median divides the data set into a lower half, and it also divides it into an upper half. Now, for the lower half, in order to find Q1, we need to go and look at that. So we look at the lower half, which is just 2, 3, 5, 7, and we need to include 8 because, you know, the data is cut into 2 pieces. We can't just look at this guy. We can't just look at these 4 values as being the lower half of the data set because then we're leaving out our 8. It does participate, right? So when you have an odd number of values in your data set, then the middle number is going to be your median, and you need to go ahead and include it in the upper and the lower half. You got to choose some convention, and that's what we choose to do. We choose to include it. So now here's our lower half. We look for a median value. The 5 is median of what's in here, so this is Q1. Very, very simple. And then we go over here, and we do exactly the same thing over here. So we look at the upper half. And we have to do the same thing. You cannot just throw away data. You have to include it somehow. And the fairest way to include it is to go ahead and keep this middle value in the lower half of the data and in the upper half of the data if you have an odd number of values like we do here. So now we have 6 values to choose from, and I think you would agree that the number 10 is in the middle, so that's Q3. So if you were to write down the quartiles of this data set, you would say Q1 is equal to 5, Q2 is equal to 8, and Q3 is equal to 10. So this is 10. And these are the 3 values, 5, 8, and 10. All right? It's really not too hard. Now we're going to do one more because I would like to show you what happens when your data set is not odd like that, when your data set's even. And so I would like to find the quartiles of these numbers, 10, 12, 14, 15, 14, 16, 17, 18, 10, 19, 17, 17. A lot more data values. But just like always, we need to order them. We need to order them. So let's order them to find medians. Of course, we have to do that. Lowest value I have here is 10. I have 2 10s. So I have 10 and 10, then 12, then 14, then 14, then 15, then 16. Then I have 3 17s in this data set, so that comes next. Then I have an 18, and then I have a 19. Let's double check. All right, so let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why I've done my ordering correctly, I think, at least. So what I want to do is look and find the middle value, which is going to be Q2, or the median here. And since I have 12 values, there's not going to be any single value in the middle. So really the 2 middle values are 15 and 16. And the average here, I don't even need to calculate it because you know that halfway between here, 15 plus 16 divided by 2, you're going to get 15.5. So that is basically the median of this data set. You kind of average the middle two values, and you get 15.5. All right, and then let's go and take a look at the lower half of this data set. So for the lower half, we have 10, 10, 12, 14, 14, and now we need to include 15 because the lower half of the data set is one half of the data set. This is 1, 2, 3, 4, 5, 6 values. This is 1, 2, 3, 4, 5, 6 values. This is why I wanted to do this problem. Whenever you have an even number of data values, then for your lower half, you need to go all the way up and include half of the values. And then here for the upper half, we'll have these values. It's a little bit different than what we did last time when we had an even number, but this is how you handle it in both cases. So then we go and look, what's the median here? And we see we don't have a single number in the middle. We have 12 and 14, and you know that the average value between here is just 13. That's halfway between 12 and 14, so that's the first quartile. Now finally for the upper half, we have 15, 16, 17, 17, 17, 18, 19. All right, we have 6 values. We chose to include, actually I was wrong, we don't include 15, make sure we're all paying attention here. We include 16 because this is half of the data set. 1, 2, 3, 4, 5, 6 values. 6 values, 6 values, that's the upper half of the data set. And then we look here and we say, well, what do we have to calculate this median? These two 17s are right in the middle. So the upper quartile Q3 is going to be the average value of those two numbers. And when you average the same number together, you're just going to get 17. 17 plus 17 divided by 2. And so ultimately, Q1 is 13, Q2 is 15.5, and Q3 is 17. And these are the final answers. The first quartile is 13, and then we have 15.5, and then we have 17. This idea of quartiles is not hard, but you need to know the difference. When we had an even number of data values, this is an even number, then for Q2, it's going to actually be the center value of your data set. For Q1, you need to have a lower half that includes the middle because you have to put it somewhere. You can't throw out data. So we choose to include the middle value in both the upper and the lower half to find the other quartiles. When we have an even number of data values, you average the middle two to find your median. And then when you find the lower half, you go all the way up and include that number. And when you have the upper half, you go all the way up and include that number. Again, we're not throwing any data away for any of it. And then we find the medians by averaging in all cases like we do. So that's how you find quartiles. It's just a few numbers that you pull out of these data sets that just help you describe what you're basically looking at. And again, you basically know that all of the data in this data set, 25% of the data lie below the value of 5, 50% lie below the value of 8, and 75% lie below the value of 10. And that's it's just kind of some key numbers to pull out that help you describe your data set. We're also going to use the concept of quartiles when we get over into showing you what a box and whisker plot is, which you'll see quite a bit in statistics. And that's kind of one of the main reasons I wanted to show you this as well. Make sure you understand this and then follow me on into the next section where we will apply it to draw these box and whisker plots.